In this video, we're going to do another Lagrange multipliers example. So let's say we're looking to find the maximum and minimum values of the function x squared, y squared, z squared, subject to x squared plus y squared plus z squared equals 1. All right, so hopefully, clearly that the minimum value that this can take on is 0. Hopefully it's pretty clear. The minimum value this can take on is 0 when 1 or 2 of these is equal to 0, but not the third. So for example, 0, 0, 1 would give us 0 out for the function. Certainly 0 is the smallest we could possibly ever get because things are being squared here. And I can certainly find points on the constraint that satisfy that equation that have one of the coordinates equal to 0. All right. So let's suppose that none of the coordinates are 0. Let's set up our system of equations using our Lagrange multipliers. Here's our partials with respect to x, y, and z for f. And we're going to set that equal to a constant times the partials of f, x, y, and z for g. And then our fourth equation in this case will be the constraint equation. We're assuming that none of the coordinates is 0, so we can divide by 2x, 2y, and 2z, we get the equations y squared, z squared equals x squared, z squared. So this two would tell you that x squared and y squared are the same. And then we also get x squared, y squared equals the other two, which tells us that, in particular, the y squared and the z squared have to be the same. So it tells us that the square of x and the square of y and the square of z are all the same value. We can plug these now into our constraint equation. We get x squared plus x squared plus x squared equals a third. That should say that x squared plus x squared plus x squared equals 1. That should be a 1 right there, not a 1/3, because we're just plugging it into the constraint equation. My apologies for the typo. When we divide by 3, we'll get x squared is equal to a third. So each of the squares of the coordinates is a third. So there are 8 possible points that we would have, plus or minus the 1 over root 3 for each of the coordinates. But it doesn't matter what if it's plus or minus. When we plug in those 3 values for x, y, and z, we're always going to get 1/27th. So that'll be our maximum value of the function subject to that constraint.